had to match these guys up. Does anybody have trouble matching them up? Your transformations are extremely helpful. You know your quadratic, your parabola, the core graph, it has a vertex of 0, 0. So first of all, if it's opening down, you know it has to have a negative. If it's opening up, you have to have a positive. So that helps, like, give you a little bit of a heads up. And you know where your transformations are. This has a reflection and a horizontal shift to the right, which means I have a minus inside. This had a vertical 3, which means I'm looking for the plus 3. This guy has a horizontal shift to the right. It's got to have a minus in here. This guy has a vertical shift up and a reflection. I got to see the reflection in here. Okay? And this you could write negative x squared plus 3. That one works either way. God bless you. I like it better this way, negative x squared plus 3, because we hit the x, we do the reflection, then we do the shift. Okay. What happens if you do this reverse? This is a good one to look at. If you did your shift first, watch what happens. You come up here, you do your shift, you're up here. Now if you do your reflection, you're over here. It's a completely different graph. This is a good one to say. Order of operations definitely makes a difference. So go to the x, do this guy first, do your reflection, then your vertical shift. Right? Not a lot of them make that much difference. The reflections on these guys, whenever we have a reflection, it does. Okay. Here's your basic transformations. And again, I had to review the transformations because this is how you graph. You graph from your transformations. We're going to be putting your quadratics out of your quadratic form and into your vertex, your standard form. From this, you can graph using your transformations. From your quadratic, you can't. You may figure out your roots. You probably can figure out a turning point in your head sometime. But you can graph from your vertex points using all of your transformations, which we have been doing up to now. So all I wanted you to do is kind of go through, describe the transformation. There's a reflection over your x-axis. Can you confirm these right now with your calculators? Absolutely. Number 11 is horizontal, and time it's by the x, it's horizontal. Outside of the x, it's vertical. The horizontal goes the opposite way. So horizontal to the left, 3 units. You can find your vertex. So now you know your vertex as well. Even if you didn't do it this way, can you pull out your H and K? Can you do that? There's your vertex using your formula, right? There's no K, so that must be 0. And remember, it's x minus h, it comes out the opposite way. So you can find your vertex either using your transformations or using the form for this. Again, this is a plus 0, so your vertex is negative 1, 0. X minus h, so that helps. Horizontal shift to the left, 1. I can physically see my vertex, negative 1, 0. And a horizontal shift to the right, 3. So 3, 0 is your vertex. So they make sense now that you're looking at them, putting the pieces together, the way we looked at them before? Alright, complete the squares. I'm going to flip this to the one without the answers, so we can walk through each one of these. I want to make sure everybody's got complete the square now. So I didn't see a lot of complete squares. Okay. I don't want pulling out your calculator to sketch this, because starting tomorrow, we're going to be doing this without your calculators. In order to do this, we complete the square. Now, the first one, and then to factor and get two binomials, you need a trinomial, right? Or a grouping, but we're going to stick with the trinomials. So we need to have a trinomial that gives us two the same factors. That gives us our perfect square. Now, can you factor this one, 23? Can we factor this? What is this factor? X minus 4, x minus 4. Oh, aren't those the same factors? Isn't this our perfect square? So, did we have to complete the square for that? No, it was our perfect square, but that's okay. Say I wasn't thinking that because the direction said complete the square, so I wasn't thinking, oh, that must be a perfect square. So we isolate the x's, and at that, you make the third term to make your perfect square. If you add it, you also have to remember to subtract it. So what is half of negative 8? And what is 4 squared? If you add 16, you subtract 16. This piece right here made you this. So that part's good. You combine these terms, you get 0. So isn't that the same thing? Does it work either way? Absolutely. It was a perfect square, and because the direction said complete the square, you probably didn't see it. So I did it out the long way, but you can do it either way. Okay, number 25. It has a fraction. Yes. But I use the same rule. I need to find my third term to complete this square. Something for a third term. Then I have this remaining, and so if I add it, I have to subtract. So that b term is negative 1. What's half of negative 1? Negative a half. This is what we were doing when we were completing the square. We take half of your b term, negative half, square. And what's 1/2 squared? Keep the fractions. 1/2 times 1/2 is what? 1/4. Keep the fractions. So if I add 1/4, I subtract 1/4. Ha! These denominators are the same, so it's 5 minus 1. 4, which is 1. So what's my vertex for this guy? 1/2? 1. Good. Which way is it opening? Up. So I can come here, I can use my transformations. Shift to the left or to the right? To the right. Here's my 1/2. Shift to the right 1/2 and up 1. Tomorrow we're going to add your intercepts in here to make sure that we cross where we're supposed to cross. Did you used to go here before? No? Because you look so familiar. I mean, I know I talked to you yesterday, but then after I was thinking, I look very familiar. Alright, are we good with this? You need to be able to complete the square. One nice thing about your calculator is you can put this in your y1. I was telling you this yesterday. Put this in your y2. They have to be the same. Now I think it was with Wilt. Didn't we catch one that the transformation was off? Because we made a mistake. We didn't take the opposite when we added. So what happens is this. If I do this on my calculator, and it's supposed to be here, and I get a graph and I'm slightly below it, my problem is in my vertical shift, or I'm slightly above it, right? If I get a graph and I'm slightly to the right or to the left of it, it's in my horizontal section, over here. It almost kind of tells me, where should I look? Where should I look at my map work that I did? I did something wrong. Look in that area. Our next thing we're going to do is all of this without your calculators at all. So you've got to know how to complete the square. Now, a negative Your a has to be 1. The number in front of your x squared has to be 1. Cannot be negative 1. So, of this little grouping, even though we isolate it, we have to take out a negative 1. We have to make this be 1. So we take out a negative 1, which means we switch the signs. We give ourselves our third term. We have our plus 5. We have our minus something. Now the reason why this new term doesn't go to a minus is because, remember, we're squaring something to put there. Whether we square a negative or we square a positive, it's always positive. So we do the same routine. What's half of negative 2? Negative 1. Squared. What's 1 squared? So your negative 1 squared is what? 1. Now, that guy is stuck inside those parentheses. In order to get him out of that parentheses, we have to distribute out. So what's negative 1 times 1? Negative 1. What's a negative of a negative? Positive. Don't forget to bring this guy down. Which way does this make your parabola open up? Down. So, that's my reflection. So I start here, I move to the right one, I move up 6, and I give myself a reflection. So instead of going up here, oops, sorry, wrong direction. Move to the right one. We reflect first, so we come down here, and we move up 6. We should end up here. To the right one on my board's a little bit off. And get our reflection, and then do our shift. Again, whatever operations matters when you do these times. They matter. Okay? How many of you could not do 29? Okay? Be honest, because we need to be able to do this. Again, A has to be 1. I don't care what the rest of it says, A has to be 1. So out of this group, we just got to get that 4 out there. So we're going to factor out a 4. Factor out a 4 out of both of the x's. Don't factor out the x, which you need the square part of it. Plus something. We still have this. A lot of times what happens, and that happens to me when I do this, I'm so concentrating on taking out a fraction or a negative or a number that I forget to bring the other term down. So make sure you bring that one down as well. Now, this guy says take half of negative 1. What is half of negative 1? Negative half. Keep the fractions. What's 1/2 squared? 1/4. Now, I got to get that out of the parentheses. What's 4 times 1/4? 1. What's 21 minus 1? And what else do I have to do here before I'm done? What's missing? From my
4.
4. Good. Gotta break down this 4. Don't forget that 4. Otherwise you change the problem if you forget it. So here's my vertex form. What does the 4 do in terms of a transformation? Stretch. Vertical stretch. So I move to which direction? The right. The right 1/2 up 20. And I stretch it so I'm getting kind of a narrow graph up here. And again, my board's just a little bit off again than usual. 31. 31's a little different. What should we do with 31? How did you guys solve this? Okay, you want to distribute your negative and just get everything out of the parentheses? That's a good way to start. Okay, oops. My board is acting up. That blue stuff. And back. It's like it's possessed. Okay. But I swore after first period I'm not going to let these set my days off every time something technical happens. Now what do I do? You take it back out of only your X's. So I'll show you a shortcut after we do this. This way I don't confuse anybody. Leave the 3, sit by itself. It's a good way to start. So now, what's half of 2? What's 1 squared? What's negative 1 times 1? And that's what goes here. What's 3 minus a negative 1? 4. And don't forget to bring down your negative. That's what makes it open down. What's the vertex? Good, because which way are you going to shift? To the left, to the negative. Okay? And you have a reflection and you have a vertical shift. Now, if you wanted to, this is already factored out of this little piece right here, right? All you want to do is remove the 3 from this mess. So if you factored this just to the 3 and took this out, you would still get this. Did you get that? You just took the 3 out of the mix. And then make yourself a little space and complete your square. That would work too. But if you don't see that, do it this way. Factor in the negative 1 and start from scratch. I think it allows you to see your groupings a little bit better than when they're all stuck in the parentheses. If you didn't do this, I want everybody to do number 33. If you didn't have 33 done, let's take a minute and do it. Let's do this one. So, first step, group these. What do I take out? Negative 2. What's left? Good. Plus something. Minus 31. Now, even though that's a minus, you added this over here. You got to subtract this over here. Okay? What's half of negative 8? Good. What's negative 4 squared? 16. And what am I going to subtract from the other side? Negative 32. Good. This is a negative 2 multiplied by 16 to get it out of there. This gives me negative 32. What a mess. Negative 31 minus a negative 32. What does that give me? 1. If you can't do it in your head, put it in your calculator. Bring down your negative 2. Otherwise your graph is not going to open up right or be dilated. Where's my vertex? Number 1. Which way is this opening? Down. Good. So if I wanted to do this, I would start at my core, go to the right 4. Just bring my little graph here. Dilate it. Give it a little stretch. Give it a little reflection. And then give it a shift up 1. Okay? And that's where we would end up. Can everybody do complete the squares? You've got to be able to do these. Your graph came out wrong?
Reflection over the one I, the original and then
No.
the one I got is right. It says the original is over.
This should be X minus 1 as well. Did you get X minus 1 in that? That's a negative 8, so you see you roll over with a negative. That should make the difference. Okay.
letting me do this. I'm not sure why my board's not working.
Let's start with these two, and then I'll give you the points for the bottom ones so you can work on the bottom ones tonight. Remember, you have a format to follow. HK is your vertex. Keep thinking the way you do transformations, because that's going to help you figure out which way everything is going. And then inside the parentheses, it's always the opposite. So if this is my H and my K, I plug those in. Because that's what I can see first. Get rid of my H and my K. Minus a -1 gives me a +1. And isn't that true that I shifted 1 to the left, so I must be a +1 in the parentheses? Makes sense? And my K +4. Now my problem is, I need to know A. So find either one of these, and I'll do the one with the positive rather than the negative. Make it an XY point. It is the solution of your equation, because isn't that a point on your parabola? So it is a solution. So if I plug in the X and the Y, I will eliminate everything but A. So this is my Y. This is my X. What's 2 squared? 4. Subtract 4. And A is -1. Bring that back in right here. You have to finish this. Doesn't this open down? See the open down part? There's the equation of this graph. Now, same holds for the other one. You have a vertex, you have a point on your graph, you have a solution to your equation. So this point represents your X and your Y. This represents your H and your K. How would I set this up? X what? +2, right? It's going the opposite way, right? Then what? Minus what? 1. Good. Now, I've got my H and my K in there, and I have one solution. I have an X and a Y. So plug those in. What's 2 squared? 4. Subtract, add 1. And phase 1. Don't forget to bring it back to this point. Okay? Now, what I need you to do at the bottom, right? But let me give you the points that didn't come out. For some odd reason, they didn't want to come out there. So tonight you're just going to finish the bottom 3 using these points. Okay. For 39, use the point 0.9. For 41, use the point -114. And the last one, use the point -2, -21/5. And yes, you get a very ugly looking fraction, but I want you to work that out with a fraction in it. Okay?